Hi, dear doctors Hartley, Nussbaum, Crippen, and Sadler. Thank you for taking the time to view this video. It needs to be shorter than 5 minutes due to software limitations, so I will get right to it. This is the G-Power software. 3 is the most recent version. It's primarily used for power analyses and calculating sample sizes. It was recommended by Dr. Nussbaum. I'm looking to do a factorial Mankova, so I need to select F-test. Over here we have the MANOVAs, repeated measures, and global effects for the main effect, and then I need to select MANOVA, special effects, and interactions would be appropriate. Over here for the type of power analysis, the proper selection for me at this time would be this one, a priori, compute required sample size given alpha, error probability, power, and effect size. I'll read this for you in case it's too small for you to read. The effect size, f squared, default value is 0.25, which is relatively high according to literature. The alpha or error probability of 0.05 is appropriate for our field, and the power over here of 0.95 is certainly high and adequate. When looking at the number of groups, there needs to be a slight adjustment here. 4 would not be the number I need to enter based on this resource that talks about even the use of G-Power. I liked it because it had many examples, including one on Mankova. And according to that resource and some others, it says that if K is the number of groups in the design and G is the number of covariates, then groups equals K plus G, which means that I need to fill in here the number 5 for groups plus the one covariate now, prior knowledge on content matter. The number of predictors or independent variables is 2, the type of list and the spatial placement of the list, and the response variables or dependent variables is 2. So I hope I said independent over here. Independent variables and dependent variables. When doing this calculation, the recommended total sample size is 40, which I thought would be low. Of course, when computing this with a even higher effect size of 0.35, considered high, the total sample size is 30. However, based on this resource, the effect size of f squared equaling 0.15 is considered medium. So the effect size f squared of 0.15 is medium, and when doing this computation with an estimated medium effect size of 0.15, the total sample size is 65. Now, I thought that maybe the safer way to go would be to humbly estimate a slightly lower than medium effect size, say of 0.12, in order to have the recommended total sample size of 80. Total sample size 80. So basically, to summarize, at a p of 0.05 and power of 0.95, which is adequately high, the high effect sizes of 0.35, 0.25 generate very small sample sizes. So I would like to recommend to use a medium, slightly lower than medium effect size of 0.12 in order to have the recommended sample size of 80. If this is agreeable with everybody, please just email me back stating so, and within about 2 hours probably my laptop, sorry, I can reply, I can do the necessary adjustments in the proposal. I look forward to your reply. Thank you.